Okay, in this video, I'm going to talk about converting between binary, decimal, and hexadecimal numbering systems, which is really important for getting your CCNA, your Cisco Certified Network Associate certification. So typically, we start with learning binary, but this time I'm going to talk about first decimal, the decimal number system. Now, the decimal number system is base 10, and what that means is it has 10 characters. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and these 10 characters. It also has the place values that go up by powers of 10. And when I was a kid, that's what I was told. The decimal number system goes by powers of 10. But it also is base 10 because it has 10 characters. Now, if we want to look at that place value system, we see that we learned this in 3rd grade, or at least I was told this in 3rd grade or 2nd grade, that you have the ones place, the tens place, the hundreds place, the thousands place, and so on and so forth. And the ones place is the 10 to the 0 power is the ones place. Anything to the power of 0 is 1. And 10 to the 1 is 10. And 10 to the 2, 10 times 10 is 100. And 10 times 10 times 10, or 10 to the 3rd power, is 1,000. And so these are our place values. And we learn this as kids. And so when we're learning how to add numbers like this, we learn that if we put 2 in the hundreds place, we have 2 100s. And if I put 1 in the tens place, I have 10. And if I put 2 in the ones place, I have 2. So I've got 2 100s, 1 10, and 2 ones. And so if I was to add this up in long form, I'd be adding up 200 plus 10 plus 2, and I get 212. And the example number here is 212. And we basically were taught that in the decimal system. So the binary system is similar, but actually easier, right? Instead of base 10, it's base 2, but it also has place values which you use to add up to create the number. So let's take a look at it. So in the binary system is base 2, which means it has 2 characters, either 0 or 1. That's pretty easy. And the place values go up by powers of 2. And that's also easy because you've got the ones place, which is 2 to the 0 power, and then the twos place, 2 to the 1 power, and then the fours place, which is 2 to the 2nd power, 2 times 2. But notice these place values, they go up, they just double. So 1, 2, 4, 8, 16, 32, 64, 128. Now notice I've got 8 place values here for 8 bits, because in the computer, a lot of stuff happens in groups of 8. 8 bits is a byte, as you know. And 4 bytes is a nibble. 4 bits is a nibble, 8 bits is a byte, 4 bits is a nibble, but 4 bits is also a hex character. We'll talk about that in a second. So we're going to do the number 212 here. So the number 212 in decimal converted to binary. And to convert the number 212 to binary, all we do is we start off here, we say, okay, I want 212. How many 128s do I need? Right here, how many 128s do I need? Well, it's either 0 128s or 1. So it's either 0 or 1. So yeah, if I need 212, I'll probably take a 128. So that's a 1 right there. Then how many 64s do I need? Well, if I add 128 and 64, I get 192. So yeah, 1, give me one of those. So now I have 128, I've got 64. Those two numbers together gives me 192. Now, do I need a 32? Well, if I add 32 to 192, I get 224, which is too much. So no, 0. So I'll take a 128, I'll take a 64. I do not need a 32 because that would be too much, 224. How about a 16? Well, if I add 128 plus 64 plus 16, and I could do that right here, 128 plus 64 plus 16, I get 208. So that's right. So 128 plus 64 is 192, plus 16 is 208. So I have 208 now. I'm only 4 away from 212. So I don't need an 8, I need a 4, right? Because 208 plus 4 gives me 212. So that's all I need now is plus 4, and now I have 212. And so in long form, really what I'm doing is I'm saying 128 plus 64 plus 16 plus 4 is 212. So my number in binary is 110101000, and that's 8 bits. And it's that easy. But it would work that way no matter whatever you're doing. So if I said, hey, what if I wanted to do the number 156? Well, 156. Okay, well, what do I need? Well, I'll just change these to zeros, and I'll say, okay, I need 128. 64 is too much. 32 would be 160. That's too much. So I'll take a 16. So 128 plus 16 is 144. 144 plus 8 is 152. And now I have 152. And if I put 4 more, I've got 156. Now we can add that up again. 128, yeah, it's 144, 152, 156. And so 156 in binary is 1001 1100. And there it is, converted to binary. So that's pretty simple. Now, if we go to hexadecimal, let's look at hexadecimal. Hexadecimal follows the same construct. In hexadecimal, it's base 16. It's based on 16 characters, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then A, B, C, D, E, and F. And the A is for 10, B is 11, C is 12, 13, 14, and 15, and F is a 15 in base 16. So once again, the numbers are 0 through 9, A is a 10, B is 11, C is 12, 13, 14, and 15. The place values, this is a difficult part, go up by powers of 16. So you've got the ones place, 16 to the 0 is the ones place, 16 to the 1 is the 16s place, and then 16 to the 2 is the 256 place, and then the numbers just get really big. And, you know, this gets kind of ugly, and you're like, what? I can't deal with that. Well, guess what? In hexadecimal, you're usually not going this many place values. You're usually dealing with just 2 place values. Now, why is that? Because each character in hex is 4 bits. So 2 place values is 8 bits. So that's a byte right there. So right here, this is a byte right there, D4. Now, what does this mean right here, D4? Well, we're still trying to do here the number 212. And first of all, in hex, when we talk about hex characters, right, we write them like this, D4, or sometimes you'll see it like this, HD4, hex D4, or 0xD4, which means that this D4 is hex. Or you might see percentage sign D4, or pound or hash D4, or backslash X D4. But this basically means that what follows is a hex character. And I'll tell you why in a second here. So first of all, D4, what does this mean? Okay, it means that I've got 4 ones. And it also means that I've got D number of 16s. Well, D is 13. So this really means that I've got 13 16s. Why? Because D is 10, 11, 12, 13. So this basically means I have 13 16s. So if I wanted to basically know what I have here, I would say to myself something like this. I've got 13 times 16 plus 4. And so that's the difficult part is, well, what is 13 16s, right? That's the difficult part to write. Well, if plus 4, so I could tell you 13 times 16 is 208. And if we brought up a calculator and we said, all right, what is 13 times 16 and 208, right? So we could verify that. But converting between 212, right, to hex can be a lot easier than that when you think about the fact that each hex character, like D4 here, is 4 bits. Each character is 4 bits. In other words, if I break up the binary into 2 places, then I could say, all right, D is 13, and 13 in binary is an 8, a 4, a 0, and a 1. So that's the same as 13, okay? Which is the same as a D. And then the 4 here is the same as in binary. That would be 0, 1, 0, 0. And that equals a 4 in binary, and it also equals a 4 in hex. So in other words, if I take 1101 as my D here, which is a 13, and I take my 0100, which is a 4, as a 4 in hex, what if I put them together? What if I say, all right, let's put those numbers together. 11, 010100. So look at that, 11010100. If I put these two hex characters together in binary, what do I get? 128 plus 64 is 192, plus 16 is 208, plus 4 is 212, and I have 212. So in other words, I could break this down into binary, and then it's a lot easier to compare it or to convert it, convert the decimal to binary or the hexadecimal to binary and then into decimal. And that's pretty interesting. That's a pretty interesting combination. So once again, also, you'll notice that like two hex characters like this is oftentimes how we look at ASCII text. Will be two hexadecimal characters, and it's 8 bits, right, or a byte, and then the ASCII character represented as a byte or 2 characters. So also the other thing to know about hex is the reason that, let me just get rid of this, the reason that we have 2 characters for hex and we write it like this, 0xd4, is because what if you had a number like this, okay, 34 hex. Well, 34 hex just looks like 34 decimal. And so if you wrote it like this, 34, you would have a hard time distinguishing it between hexadecimal and decimal. So it's written like this, 0x34, and we know it's hex 34. In other words, we know that this would be 4 ones and 3 16s. And 3 16s, it'd be, let's see here, 32, 40, 48 plus 4, and this would be 52. So hex 34 is decimal 52. Why? Because 3 16s, 3 times 16 is 48, and then plus 4 is 52. So that's interesting. So I'll put that back to D4 here. All right, then I'm not going to spend a lot of time with it, but we could also talk about the octal number system. And the octal number system is similar as when we're changing it to hexadecimal. It's base 8. It's based on 8 characters, 0, 1, 2, 3, 4, 5, 6, 7. The place values go up by powers of 8. So you've got the 1's place, the 8's place, and the 64's place here. So 8 times 8 is 64. So if you want to write the number 212 or 212, right, it would be written like 0324, octal 324, or 00324, octal 324, backslash 324. And what does that mean? That means we have 4 1s, we have 2 8s, and we have 3 64s. And that's how you would add it up. I have 3 64s, 2 8s, and 4 1s, and if you add those numbers together, you get 212. Now let's do something fun. We'll move over here and we'll take a look at Base64 encoding. So Base64 encoding is pretty interesting. It's used to encode text. It's often used by hackers to obfuscate what they're doing, to hide their code, to hide their plain text by encoding it in Base64 encoding. It involves using ASCII, hexadecimal, decimal, and binary. Now, what it is based on is, instead of having like base 16, where you have 16 characters, starts off with a 64 character string. And the 64 character string looks something like this. The alphabet, A, B, C, D, all the way up to Z, capital letters, followed by the alphabet in lowercase letters, followed by the numbers 0 through 9, a plus sign, a forward slash, and then an equal sign for padding, which equals 64 total characters. So then if you want to convert text, like my name here, capital D and then lowercase a-n, Dan, and I want to convert this to Base64 encoding, what you do is first you get the hexadecimal characters, the ASCII for each letter. So hex 44, which is decimal 68, is a capital D, and a lowercase a is hex 61, decimal 97, that's a lowercase a, in ASCII, and N is 6E hexadecimal, or 110 in decimal, and that's an N on an ASCII chart. Then what you do is you take those decimal numbers on the ASCII chart and you convert it to binary. So you can see here hex 44 or 68 is in binary, right? That is right there. There's 8 bits. And you can see here, this is the 64's place. So the 64's place plus the 4's place is 68. And here's 97. Okay, 97 is like this. Right there, there's that 8 bits. 64 plus 32 is 96, plus 1 is 97. Okay, and so on and so forth. So you have 8 bits, 8 bits, and 8 bits. And this is the binary representation of 110, which is decimal, which is 6E, which is hexadecimal. Then, once you have your string of characters or your message all laid out in binary, you break it up into 6-bit chunks. So if we just look at this from 6 bits from the left, we break it into 6-bit chunks. So this would be, if we're just dealing with 6 bits, then this is the 1's place, the 2, 4, 8, 16. So this is a 16 plus a 1 is a 17. And then you take that 17 and you go 17 characters over on the 64 character string, and you end up at the letter 8. And 17 characters over with the first character being 0. So 0, 1, 2, 3, 4, 5, 6, 7, all the way up to 17, you end up with a capital R. And then over here, we do the next character here. We take 6 bits. We take 6 bits. Here we go, 6 bits. The next 6 bits, and we can see here, there's a 1. Okay, oh, I'm sorry, the next 6 bits is right here, sorry. The next 6 bits, we've got a 4 and a 2, which is a 6, and 6 characters over, 0, 1, 2, 3, 4, 5, 6, that's a G. And then the next 6 characters over is a 4 and a 1 is a 5, and that's a capital F. 0, 1, 2, 3, 4, 5, that's F. And then the last one, the last 6 bits here is 1, 0, 1, 1, 1. So this would be according to 6 bits, right? This is a 2, a 4, that's 6, an 8 is 14, and then 32, 32 plus 14 is 46. So 32 plus 8 is 40, plus 4 is 44, plus 2 is 46. If we go 46 characters over, starting with 0, we end up at a U. And so the word Dan with a capital D encoded into Base64 encoding is RGFU. Now, just to test that, just to verify, you can go to a website like base64encode.org, and I've got the encode here, and I'll put in capital D, A-N, and I'll press encode, and there it is, RGF and lowercase u, and it's encoded. So that's fun. So you could then encode your messages, but now you'd know how to decode them by hand in case you ever needed to do that. Or maybe you want to write a program that decodes or encodes for you.